All right, so today we'll look at section 2.4, which is on solving basic inequalities, okay, linear inequalities. Okay, just as a review for inequality symbols, less than or equal to, greater than or equal to, okay, in the order that I read them. Okay, so these are both examples of inequalities. The one on the left, that's just a true statement. An inequality can also be false. Okay, but 3 is less than 8.
Equal to doesn't count as a symbol?
Equal to would be an equality symbol, not an inequality symbol. The other one is 3x is greater than 12. That's a conditional inequality. Okay, it could be true if you pick the right values for x. What's a little different about a conditional inequality is there is an infinite number of answers to this problem, versus this one, there's only one answer. Okay, 4 would be the answer here. Anything greater than 4 is the answer to the one below. All right, so how do you tell if a number is a solution? Kind of like we did yesterday. You take your number, you plug it in, and you see if you get a true statement. Okay, so we'll try it with 3x is greater than 12. Cameron, if I plug in 5 for x, 3 times 5 gives me 15. Is 15 greater than 12? Yeah, so that means 5 is a solution. If I try 2, Julia, what's 3 times 2? 6. Is 6 greater than 12? No. So that means 2 is not a solution. Okay, so plug it in, see if you get a true statement. Okay, any questions on how to check if a number is a solution? All right. Okay, so one type of inequality that we deal with quite a bit is a conjunction. What word, when you think conjunctions, like in English, what word is a conjunction?
It joins 2 sentences together.
Yeah, what word joins 2 sentences? And. Yeah. So, conjunction. 2 inequalities connected with the word and. If you use the word or, that's a disjunction. Okay, that's a little different. Okay, but 2 inequalities connected with the word and. Does everybody have what's on the left? Okay, so there's a conjunction. X is greater than -1 and x is less than 3. Now you can combine that into a single inequality. Okay, and the way you combine it into one statement is you put the variable in the middle, you put the smaller number on the left, you put the bigger number on the right, and both inequalities point towards the smaller number. Okay, there is another way to do it. I usually do it this way, but you can put the variable in the middle, and you can flip everything I just said. You can put the bigger number on the left, the smaller number on the right, and then flip the direction of the arrows. That's exactly the same thing. Okay. So you've got your x is greater than -1 right there. And then you've got your x is less than 3 right there. So it's just taking those 2 and putting them together. Any questions on how to combine 2 inequalities into one, or does anyone want to see another one of those? Okay. So the way you can think of this problem is the answer for x, it's an interval. It's all numbers that are between -1 and +3. Okay, this is a between. That's how conjunctions usually work. So if I was going to graph this on a number line, there's -1, there's 3. Specifically, this is what we call an open interval because it doesn't use the equal to symbols. Open circle -1, open circle on 3, and where would you shade? In the middle. Yeah, you shade between. That's what this would look like graphed out. Okay, and again, this is called an open interval. Okay, and there's really two types of intervals you can have. You can have open or you can have closed. Or I guess you could have a mixture, like partially closed, partially open. But what's important with these kinds of intervals is you have a number for the left interval and you have a number for the right interval. Okay. Whenever you have numbers on each end of your interval, that's called a bounded interval. You might be like, well, what other kind of interval could you have? That's unbounded. Okay? Because x is greater than 4. What's the highest number that it could be? There's no limit. It's unbounded. It can go up to infinity. Right? So when you're limited between two numbers, that's called a bounded interval. Okay, so bounded interval, your bounds are numbers. Okay, so you can have a fully closed interval. Okay, so you could have something like from 2 up to 8. And the bracket means you can include the 2 and you can include the 8. Okay? You can be equal to on each end of the interval. Versus an open interval, okay, if I said an open interval between 2 and 8, what's the difference between an open interval between 2 and 8 and a closed interval?
It can only be 2 and it can only be 8, or it can be all numbers in between 2 and 8.
Well, these both are intervals. They both mean everything between 2 and 8.
It just doesn't include the 2 or the 8.
It doesn't include the 2 or the 8. Right? So it's like you can go up to like 7.99999, okay? Or 2.00001. But you can't include the 2 and you can't include the 8 on an open interval. How about on a closed interval?
Okay.
You can. You can include the 2 and you can include the 8. Okay, you can also have a half-open interval, which means include the number on the left, but you can't include the number on the right. Or you could switch that around. Okay, another half-open interval, where you don't include the number on the left, but you do include the number on the right. And that's all the different ways you could write a bounded interval. There's no other combination of things. Okay, so any question on the 4 types of bounded intervals? Okay, what other kind of intervals do you think we have besides bounded? Non-bounded or unbounded. I think your book on page 99, they have more pictures of these if you want to see them. Okay, unbounded interval. Okay, unbounded interval means that one end of your interval goes on forever. Okay, it never stops. So when you do a graph of an unbounded interval, usually it looks something like this. There's an arrow going in one direction, meaning keep going. Okay, you don't stop. Okay, these are all examples of unbounded intervals. The 2 on the left are unbounded on the left, but the first one is closed. The second one is open. Okay. On the right, these are both unbounded, but they're unbounded on the right-hand side. The first one is closed. The second one is open. Okay, so bounded intervals, don't use infinity. Unbounded intervals go on forever. They do use infinity. So any question on the difference between bounded and unbounded, open or closed? Okay, why do I put a parenthesis on infinity? Why don't I put a bracket?
Because it can't just be.
Right, you can't be infinity. You can't reach it. So you can never include infinity because you can't get there. Okay, it just goes on forever. And they draw pictures of these in your book as well. Okay, we're going to write some inequalities, and we'll do some pictures right now. Okay, so what I have here, this is interval notation. What I want to do is convert it to an inequality, okay, with an x in the middle. Okay, anyone think they could tell me how to rewrite this as an inequality? Yep, Ian.
X is greater than -3, but less than or equal to 5.
X is greater than -3, I like that. And then less than or equal to 5. Now, why did you use the equal to, like with the x is less than or equal to 5?
So it's a bracket.
Because of the bracket. You can include the 5, but you can't include the -3. That's it. Okay. Any questions on that? If they asked you to graph something like that on a number line, what kind of circle would you use on -3? Open. How about on 5? Closed. Shade between. So there's basically all three ways you could do that. Interval notation, inequality, graph. They all mean the same thing. All right. Interval from -4 to infinity. Okay, how would you write that as an inequality? And this is actually a simpler inequality than the last one, because you only have one bound. What numbers are you allowed to pick that would satisfy that interval?
X is greater than or equal to 4.
X is greater than or equal to 4. That's it. Yep. You don't have to say less than infinity. Well, of course, any number you pick is less than infinity. But all you have to say is x is greater than or equal to 4.
Wait, what?
Or negative.
-4. Okay, so any number greater than or equal to -4. Any question on that one? So what kind of interval is that? Bounded or unbounded?
Unbounded.
Unbounded. Goes on forever. Is it an open, closed, or half open interval? Yep, it's half open. This one's half open on the right. Let's just start. What kind of interval is that? Bounded or unbounded? Bounded. Open, closed, or half?
Closed.
Fully closed. Yep, fully closed interval. So Mike, you think you could tell me how I would write that one as one inequality?
Negative x is bigger than x.
X is what?
Is that bigger, even smaller than x?
Well, which one? You want greater than or less than? X is less than what number?
X.
X is less than x?
I say -8 is x.
Oh, -8 is less than x. Okay, and what else?
What?
What would be the other part?
-3 is bigger than x.
-3 is bigger than x. All right. So could anybody put that all together into one? Yeah.
-8 is less than or equal to x, which is less than or equal to 3.
Yeah, I was going to mention that too. But so he put the equal to, which we need here because of the bracket. We need another equal to on that one because of the bracket. So x is less than or equal to -3. So Mike, what you said here wasn't wrong, other than we just need that equal to. But as long as it's pointing at the x and the way you said it, it is pointing at the x. But we just want to combine it all into one. Okay. Okay. Any question on that one? Right. What kind of inequality is that called again? Yeah. So the interval is bounded, but the inequality is a, yeah, it's a conjunction. So when you pronounce this, you have to use the word and. X is greater than or equal to -8, and x is less than or equal to -3. Or you can read it other ways too. However you read it, you got to use the word and. Okay, so we'll do a couple graphs. We already did a few, but we'll practice a few more. This time I'll do the graphing with brackets and parentheses instead of open closed circle. So Hannah, if I had a number line, what kind of symbol would I put on 2? Bracket or parenthesis?
Bracket.
Bracket facing which way?
This way. Wait. The less than the left.
So you want to have it facing the numbers that are smaller than 2? Or
X is greater. Oh, no. I'm sorry,
greater
to
than?
the right.
To the right, right?
Sorry.
X is greater than or equal to 2. Okay, so that's shading everything from 2, including 2, to the right. All right, how about x is less than 5? Josh, would I use bracket or parenthesis? Parenthesis. And which way would that face?
To the left.
To the left. So parenthesis on 5 to the left, and then that's where you shade. Okay, any questions on that one? All right, let's try this one. Okay, so now we have a conjunction. AJ, what kind of symbol would I put on the -1?
Bracket.
Yep, bracket. Which way is it going to face?
Going to the left.
So you're,
Oh, wait.
yeah, you got to think of this. If you wanted to rewrite it a different way,
Yeah, okay.
it's all x is greater than or equal to -1. So shade to the right. So bracket opening right. I'm going to wait to shade because I have something else. Well, Brian, what kind of symbol on 3?
You put the parenthesis, right?
Yep. So as Braden said, parenthesis on the 3, shade. And then where would you shade, Braden?
To the left.
Would you stop anywhere?
No. I mean, yeah, at the bracket.
At the bracket. Yep. So we're just going to shade between. Okay. Any questions on that one?
How would we know when to use that versus the closed circle and open circle?
You can do either one unless the directions specifically say which ones to use. Yep. So you can use bracket or parenthesis, but don't mix them. Don't use like a closed circle and a parenthesis. Either just use the bracket parenthesis or just use open closed circle. Okay, so when they ask us to solve an inequality, we pretty much do the same steps as an equation, but there's one thing you've got to be careful about. Does anybody know what can come up when you're solving an inequality? It doesn't come up when you solve an equation. Something you have to be careful about. Has to do with multiplying and dividing.
Negatives.
What about a negative?
You can't divide by negative.
You can. You can divide by a negative.
I don't know why I said
What happens though if you do that?
Then the answer becomes a negative. If you divide it out of a positive.
Okay, if you had a positive over a negative, it would be a negative. But something else happens. When you divide each side of an inequality by a negative, what do you have to do?
Do it
Yeah.
to the other side.
You have to do it on both sides, but
You have to turn the sign around.
yeah, you have to flip the sign.
Oh, yeah.
Okay. So if you already know that, you don't have to write it down, but if you don't, I would remember it somehow. If you multiply or divide by a negative, flip the sign. Okay, so I wrote it out kind of long there. I fully explained it, but if you want to shorten it, if you multiply or divide by a negative, flip the sign. If you add or subtract, you never flip the sign. Only if you multiply or divide by a negative. And if you solve a problem in kind of a clever way, you can pretty much avoid this all the time. Depend on which side you put your x's on. Okay? But you can always put them on a certain side to avoid this problem. It's not really a problem. Okay, so let's see if we can solve this one. All right, so Curtis, would be my first step to solve that.
On that, first you distribute the 3 into the x minus 1.
Yep.
So 3x minus 3.
So that's your first step. You're going to distribute that out, and let me write down what you just said. So 3x minus 3. Is anything else changing at this step?
No.
No, not unless you're going to combine like
Yeah,
terms,
well, that's
but
the next step.
that's the next step.
So in the end, it's going to be 3x minus 1
Yep.
is less than or equal to 5x plus 6.
Okay, now if we do this the right way, we can avoid having x be a negative. So what should be my next step if I want to avoid x being a negative number? You don't have to, but yep.
Subtract 3 from both sides.
Subtract
3x.
3x. Yep. So if you do that, subtract your 3x, and then subtract 6, you get negative 7 is less than or equal to, what's 5x minus 3x? 2x. And now my last step, divide by 2, and it's a positive. So I get negative 7 halves is less than or equal to x. Now, how could you write that so the variable is on the left? Because most of the time we like to do it with x here, number here, and then your inequality symbol in the middle. Yeah, x is greater than or equal to negative 7 halves. Does anybody know the advantage to writing it the second way, especially with graphing?
You don't have to flip the sign when you're
Yeah, the sign tells you which way to shade. If you do it this way, this tells you to shade to the right because you put the variable on the left, number on the right. If you leave your answer the first way, the sign tells you the opposite way to shade. Okay, so I usually do it the second way.
Could you change it so the negative 7 halves could be negative 3 and 1/2?
You could write it as negative 3.5 or, yep. I'd say that would be helpful for graphing because then you know negative 3.5, it's in between negative 3 and 4.
But like if we had that instead of what you have on the board on a test, is that going to be wrong?
Nope, that's fine.
All right.
Yep. Okay, let's look at solving some inequalities on the graphing calculator. All right, so solving on the graphing calculator. There's really two different ways you can do it. Okay, the first method involves getting 0. on one side of the inequality, kind of like you're solving a quadratic. Get everything on one side, get 0 on the other. And if you do it that way, under the calculate menu, you're going to do a root. So you're going to calculate a root. Okay, so if you do it method 1, you would have something like this. Here's your axes. And then maybe that's your graph. Okay, you'll have a picture like that. You're going to calculate the root right there. Then, depending on the question, you have to determine where the graph is either positive or negative. So, if the question here was saying, where is this graph less than 0? Okay. Let's say, just to make it simple, let's say the root was at 2. That's where it crosses the x-axis. If you wanted to know where the graph is less than 0, that's in this section. So you would have to pick x values that are less than 2. If your problem said, where is the graph greater than 0, you would have to pick values to the right of 2. Okay, so you're either picking values to the left of your root or to the right of your root. Just depends on what the question's asking. Also, pay attention to whether or not you should be including the root. It might say greater than, or it could say greater than or equal, or less than or equal. Okay, so let's try this one.
Is the root always on the x-axis?
The root is always on the x-axis, yep. Every line except a line that's horizontal will always cross the x-axis somewhere. But if it's horizontal, it might not. Okay, so what's the first thing I would have to do with that equation?
Make it 0.
Yep, how would I do that?
Subtract 2.
Subtract 2. So I get 4x minus 3 is less than 0. Okay, now I'm going to graph that. I'm going to type in 4x minus 3. I'm going to do zoom 6. I think that'll be good. Okay, there's my picture. Okay, what I'm looking for is that x value right there. Okay, if you pick x values that are less than that, your graph would be less than 0. If you pick x values that are bigger than that, then your y value would be greater than 0. Okay, I want to be less than 0. So I need to pick x values from here that way. Okay? Any x value that's to the left of that red one will cause the y value to be negative. And that's what they want. Negative. Less than 0. Okay, so let's do second calc 0. Pick a point left, right, guess, and we get 0.75. Okay, that's where that root is. That's the coordinate of it. 0.75 comma 0. So would I pick x values that are less than 0.75 or more than 0.75? How about Miley? What's that? Yeah, we'd pick less than. Right? If you pick x values that are down in here, then your y value is going to be way, it's off the screen. It's going to be way down there somewhere. And that's what you want. You want y values less than 0. So pick x's that are less than 0.75. What if you pick x's that were more than 0.75? Like what if you pick one over here? What would happen to your y value there?
Go up.
It would go up. It would be positive. Okay? It would be somewhere up here. Okay? They didn't want positive. They wanted negative, less than 0. Any questions on that? Okay, so that's one method to calculate or solve an inequality on the calculator. Okay, calculate a root. Okay, second method. The second method is going to involve finding an intersect. So the advantage of finding an intersect is that you don't have to rearrange it and get 0 by itself. You leave it the way it is. So we're going to do the same problem again, but this time we'll do it as an intersect. Keep what's on the left in y1. Put what's on the right in y2. And then see where they cross. And then just like before, once you find where they cross, you have to determine, do you want x's that are below that point? Okay, is this like a less than 0 problem? Or do you want x's above that point? Is this a greater than 0 problem? Okay, so let's type this in again. All right, so again, this time I'm not rearranging it. I'm going to leave the left just the way it is. Leave the right just the way it is. Okay, hit graph. Here's 4x minus 1. There's y equals 2. Okay, 4x minus 1, that's the blue graph. Okay, so if that one's blue. Y equals 2, that's the red one. So what I'm looking for is where is the blue graph less than the red graph. So first, let's find exactly where they cross. So second calc, intersect. So they cross at 0.75. Would I want x values below 0.75 or above?
Wait, how do you get 0.75? My calculator doesn't say that.
So you type that in for y1 and y2.
Yeah, I did all the same exact things, but I think just because my calculator is different, it reads different.
And then second calc, you did intersect.
Mm-hmm.
And then you pick a point on the blue. Pick a point on the red, or if yours is black and white, pick a point on the first one, pick a point on the second one. And then hit enter for the guess. And that's your intersect. So after you do second calc intersect, you've got to hit enter 3 times.
You should pick a random point on both lines? Or?
Yeah, basically just hit enter 3 times. For this problem, it doesn't matter.
Oh, I got you.
Gotcha? All right.
Wow.
So now, would I want x values below that or above that? Oh, Ezekiel? Below, right? What you're looking for is where the blue graph is under the red graph. That happens in that section. Okay? Values that are to the left of the intersection point. If you pick an x value to the right, like let's say you pick 2. Well, at 2, the blue graph is above the red graph. That's not what they wanted. Blue graph less than red graph. Okay, so everything below 0.75. Okay, so example 5, that's what we just did. We solved the same problem we did in example 4, except I did it as an intersect. Okay, any question on the difference between doing it as an intersect or as a root?
My calculator said no signage change when I
You probably did 0. Like if you do second calculate 0, which is the wrong way to do this one.
What was I supposed to do?
Intersect.
intersect.
Oh, okay, right.
I don't get the same error as you, but I get an error if I do that. Okay, any other questions on that? All right, let's look at this one. So when you're solving a conjunction, it's pretty much exactly the same as what we've been doing all along, except you have three parts. So whatever you do to the middle, you have to do on the left, and you have to do on the right. Okay, so the goal is to still get x by itself in the middle. You just have to do stuff in three parts instead of just two. All the same rules still apply. If you multiply by a negative, flip the sign. If you divide by a negative, you flip all the signs. Same rules. All right, so let's see if we can solve that one. Okay, anyone think they could tell me what my first step would be to start getting x by itself in the middle? There's going to be 3 steps. Yep, Andrew?
Multiply by 3.
Yep. First step is to multiply everything by 3. So that's going to give me negative 9. Those 3's are going to cancel out. And we get 2x plus 5. And Andrew, what's going to be on the right-hand side now?
15.
15. Good. All right. How about my second step? David, you think you can tell me what my second step would be?
You would try to get the x on its own.
Mm-hmm.
So you would get rid of the 5,
Yep. How would you get rid of the 5?
take it away from both sides.
Take it away from both sides and from the... Where else?
Middle.
The middle, right? So do it on both sides.
That's what I meant by that.
Okay. And in the middle.
And then divide the 2.
And then we'll divide by 2. So let's just do that first. So negative 9 minus 5 is negative 14. 15 minus 5 is 10. And then the last step you said,
Divide the 2
divide by 2
on all sides.
everywhere. Yeah. Divide by 2 everywhere. Do I need to flip my inequality sign?
No.
Nope. I divided by a positive 2. So we get negative 7 is less than x, less than or equal to 5. Okay, so any question on solving a conjunction with x in the middle? Okay. All right, so the last thing we'll look at today will be absolute value inequality. So yesterday we did absolute value equations. What was your first step when you do an absolute value equation? What do you have to make sure of? You have to make sure it's by itself. That's the first thing. Make sure the absolute value is by itself. And then from there, we split it into 2 problems. Okay? These steps are going to be almost identical to what we did yesterday. Does anyone remember when you split it into 2 problems, how you get the first one you split it into? You just have to do one thing.
Take out the absolute value sign.
Yeah, just take out the absolute value bars. So the first one you split it into, it's exactly the same as what you started with, just take out the bars. Now, how about the second one? You had to do one extra thing. What did you have to do?
Add a negative to the to like.
So yeah, the second inequality you're still going to take out the bars, and you're still going to make the number on the other side, well, you're going to change the sign of it. If it's negative, make it positive. If it's positive, make it negative. But when you make something negative in an inequality, what else do you have to do? And that's the extra step here. If you make that number on the other side negative, what do you have to do with the sign? You have to flip it. So that's the extra step today. First step's the same. Second step, that's the only thing that's different, what I underlined in red. You still take out the bars, you still change the number on the other side, but you've got to remember to flip the sign. And now yesterday when we had our two answers, we had something like x equals, we got an answer, x equals, we got an answer, and what word did we put between them?
And?
Yeah, I think we put and. Hope we did. So it's both of those. They were both answers. X is this and this. Well, today you have a choice. You're either going to use the word and, or you use the word or. Which one you use, just go back to the original problem. Okay, look at the question. If the original problem has a less than or a less than or equal to, you use an and. If the original problem was a greater than or equal to, you use an or. We've already been kind of using the word or when we do set notation. We've used that U symbol before. That means union. But for now, you don't really have to worry about that. So less than uses an and. That's how I remember it. Land. Less than's and. Okay. Greater than gore. Greater than's use an or. So if that trick helps you to remember which one is which, you could use that. Okay, so we'll try one absolute value by hand. Then I'm going to skip that one. We'll try one on the calculator, and that'll be it. All right. First of all, is the absolute value expression by itself there?
Yeah.
Yep, we're good to go. We can split it up. Can someone give me my first inequality that'll split up into? Ian?
X minus 3 is less than 3.
Yep, x minus 3 is less than 3. Can you give me the second one too?
X minus 3 is greater than negative 3.
Perfect. Took out the bars, made it negative, flipped the sign. So Casey, when I solve the one on the left, what do I get?
6.
Yep. X is less than 6. How about when I solve the one on the right, about Hannah?
Me?
Yeah, Hannah. C.
I have no idea.
How do you get x? What do you have to do to get x by itself
Add
there?
3 to both sides.
Yeah, so what do you get when you add 3 to both sides?
0.
X is greater than 0. And what word should I put between? And or? And. The original symbol is a less than. If you have a less than, you put an and. If you forgot or you put the wrong word on a test, I'd probably take a point off for the and or. But just make sure you remember that. Okay. Any questions before we finish up with one on the calculator? Question?
Oh, no, sorry.
That's pretty much the same thing. So I'm going to skip that one. That would be an or because it's a greater than. Let's try this. Okay, so for this one, we're looking where this graph is greater than 0. Okay, and the real reason I want to do it is just so we remember where absolute value is. Okay. How should I type that in?
X.
Even before that.
Oh.
Something I need to put down before I type in x plus 3. If I don't, it won't graph correctly. Parentheses, yep. Now you don't need parentheses around the bottom because the absolute values are already a grouping symbol. Does anyone remember where the absolute values are?
Math and number.
Yep, we're going to go to math. Going to go to number, and it's the first option, absolute value. Okay, so let's graph that and see what it looks like. All right. On the right-hand side, does it ever look like it's coming back down below 0?
Going back down below 0?
Yeah, it's coming down, but does it ever look like it's going to get below 0? No. If you zoom out, you can see that. So it's never going to come below 0. It's basically going to go like this. It's pretty much going to look horizontal after a while. What value are you not allowed to plug in for x here? Because if you did, you'd divide by 0. 2. So you have to remember, x can't be 2. So this graph is going to be greater than 0, basically from this point on. You can pick anything from here. Let's just call that A. Yeah, it has a number, you'd have to find it. So you can pick anything from A going to the right, except you can't pick which number. You can't pick 2. So any value greater than A, you would have to find A on your calculator doing second calc root. So any value greater than A except 2. Okay, so that one's a little tricky because it's got the absolute value in it. Any question on that one? Okay, in the homework, there's a few of those, so we'll talk more about them tomorrow when we go over homework. Okay, so homework tonight, it's on 108. If you need any help, I will be after school on Thursday, and we have our test on Friday.